acids and bases. Let us see the chemistry between an acid and a base, and let us also see how acids and bases react with other elements and compounds around them. Let's begin seeing how acids react with metals. For that, we do one activity. We take a test tube which has zinc granules in it, and we add sulfuric acid to the test tube to check how the metal zinc reacts with sulfuric acid. And through the cork, we have a delivery tube which passes through the soap solution. Now, can you see some bubbles occurring in the test tube? This indicates that a gas is evolved. And it also indicates that a reaction has taken place between zinc and sulfuric acid. Now, the gas which is evolved is colorless and odorless. So, we have to check which gas is evolved. The gas passes through the delivery tube and it passes through the soap solution. We can see bubbles in the soap solution. This indicates that the gas has passed through the soap solution. Now, with a candle, we will check the bubbles that have occurred. When we put the candle near the bubble, the gas in the bubble burns with a pop sound. This indicates that the gas evolved is hydrogen gas because it has the property of burning with a pop sound. So now we know that when zinc reacts with sulfuric acid, a gas is produced which is hydrogen. But there is one more substance produced during the reaction. Let us understand this by using an equation. We had zinc, that is solid, plus H2SO4, that is sulfuric acid, and acids are aqueous, so AQ. Now, any metal to react with acid has to displace hydrogen from the acid's formula. So, when zinc displaces hydrogen from the formula, it forms zinc sulfate. And zinc's valency is 2, sulfate valency 2, so the formula is ZnSO4. And hydrogen gas is evolved, so plus H2. Okay, now we can repeat the same activity using hydrochloric acid. So we put dilute hydrochloric acid in the test tube instead of sulfuric acid. We find the same thing happening. We see bubbles in the soap solution, and when we test the gas, it is hydrogen. So here two hydrogen gases form. So when we have to write our equation, it will be zinc plus HCl. Zinc displaces hydrogen from HCl and forms hydrogen gas, and it forms zinc chloride salt. So the entire reaction becomes Zn plus HCl gives ZnCl2 plus H2. This means that metals react with acids to form salt and hydrogen gas. But instead of hydrochloric acid, we take acetic acid. Do we find the same thing happening? Yes, but here the amount of hydrogen released is less this time. That is because acids like acetic acid are weak acids. So when they react, they do not produce much of hydrogen gas. Do all metals react with acids? Not necessarily. A metal to react with acid has to displace hydrogen from the acid. But when we check the reactivity series, we find that there are metals lying below hydrogen in the reactivity series, that is copper, silver, gold, mercury. So these metals are less reactive than hydrogen, so they will not be able to displace hydrogen from acids. So such metals generally do not react with acids. Metals which are more reactive than hydrogen displace hydrogen from the acids and form salt and hydrogen gas. Now let's come to bases. Bases reacts with metal and forms salt and hydrogen. Here too the metal has to displace hydrogen from the base. But not all metals react with bases. Only metals like zinc and aluminium react with bases. Bases are electron donors and even metals are electron donors. So substances which have like nature generally do not react with each other. Now let us see the exceptions. Okay, we have zinc, that is Zn, it reacts with NaOH, that is a strong base, and on heating it displaces the hydrogen from the base and it forms sodium zincate and hydrogen gas. Now sodium zincate's formula is Na2ZnO2. Reason, because sodium's valency is 1 and zincate's valency is 2. So when you cross multiply, the formula becomes Na2ZnO2. Now let us see the chemistry between acid and a base. For that, we do an activity. We take a test tube and we add some NaOH solution to it, that is sodium hydroxide solution, which is a base. Now to this solution, drop by drop, we add phenolphthalein solution. Now phenolphthalein is used as an indicator. In acids it remains colorless, whereas in bases it becomes pink. Okay, as soon as we add phenolphthalein to the solution turns pink. Now slowly we shall add hydrochloric acid to this mixture. When we add hydrochloric acid drop by drop, we see slowly the color of the solution vanishes and it becomes colorless. Now we again add sodium hydroxide solution to the mixture. We see that slowly the pink color is reappearing. Why does this happen? This is because the effect of a base is nullified by an acid and the effect of an acid is nullified by a base. If they are present in equal amount, the solution becomes neutral, but if acid is more, the solution becomes acidic. If the base is more, the solution becomes basic. Now let us see when acid and base reacts, what is formed. When an acid reacts with a base, salt and water are formed. Now this process is called neutralization reaction. So neutralization reaction is defined as reaction of an acid with a base forming salt and water. Now let's write an equation of our activity. We took sodium hydroxide, which is written as NaOH. It is aqueous. We added hydrochloric acid to it, which is HCl, again aqueous. Now when they react, what happens is the OH from the base and H from the acid react and form water, whereas the part remaining forms the salt. So from sodium hydroxide, sodium is remaining, and from hydrogen chloride, that is hydrochloric acid, Cl is remaining. They combine and form sodium chloride. So sodium chloride is aqueous, whereas water is liquid. Let's take one more example. Suppose we take calcium hydroxide and we add sulfuric acid to it. So our reaction becomes CaOH twice plus H2SO4. Now here OH from calcium hydroxide and H from the acid forms water, and the remaining part, that is calcium and sulfate, forms the salt. So the balanced equation becomes calcium hydroxide CaOH twice plus sulfuric acid, that is H2SO4, gives calcium sulfate, that is CaSO4 plus 2H2O.